Hi, everybody. Welcome to ICLR's Friday Forum for August 9th, 2024. I'm your host, Dr. Keith Porter, ICLR's Chief Engineer. I'm speaking to you from London, Ontario today. This is webinar 220 in a series hosted by ICLR, the Institute for Catastrophic Loss Reduction. ICLR is Canada's leading source for disaster resilience knowledge. Each month, we present recently completed research related to ICLR's mission to make Canada more resilient to natural disasters. Last month, Doctors Reza Najafi and Mohammed Fareshtapour explained how megacities around the world do climate-resilient stormwater management. The next two Friday Fora are unusual. Next week, on Friday, August the 16th, I'm going to speak. I'm going to offer some initial lessons learned from the Jasper wildfire, and I do mean initial. I still smell soot on my boots. Then on September 13th, I'm going to speak again on the cost effectiveness of above code wind design for buildings. And I'm going to show that above code design costs society less to own its buildings in the long run. But today we are staying with our topic of flood protection. We're looking at this topic domestically in the City of Richmond, British Columbia. Our speakers are Eric Sparolin and P.Eng. Eric is Richmond's Manager of Engineering, Design, and Construction. He's going to tell us about his city's flood mitigation strategy and its resilience goals. He's promised us innovative risk reduction strategies, and he's also going to speak about long-term infrastructure investments. Eric is a professional engineer. He offers expertise based on 18 or more years of flood planning and protection for the City of Richmond, and another 7+ years of prior experience, including work in the private sector. Thomas is the risk manager for the City of Richmond. He's going to be fielding questions about insurance or other aspects of risk management. Thanks for joining us, gentlemen. Before our speakers begin, here's our agenda. Our webinar is going to last 90 minutes. Our speakers will present for about half that time, then I'm going to moderate Q&A for the rest of the time. Please feel free to chat your questions into the Q&A box. I'll try to pose your questions in the order they appear in the Q&A box. So if we have a lot of questions, I may only pose your first question, then move on to others, then circle back to any additional questions that you want to ask. Our webinar is recorded, and ICLR is going to post our speakers' slides and a link to the video on Monday or so. So if you have colleagues who couldn't attend, let them know. You'll find the video and a PDF of the deck at www.iclr.org/workshops. And now I'm going to turn it over to our speakers. Eric, the floor is yours.
All right, thank you, Keith. I'm very excited to be able to share with you the exciting work we're doing at the City of Richmond in terms of flood protection. So what does a bad day in flood protection look like? In short, we came up with there's a lot of water where we don't want it, lots of water where it shouldn't be. And how about that day start? Maybe it's raining, maybe it's a high tide, maybe there's a couple events happening. Could be an earthquake, could be different things. Could also be a nice hot spring day. Maybe there's lots of snow in the mountains and that snowpack is melting and it's coming down the river, causing high water levels in our river. Just recently, I don't know how much of you have been watching the news, but just in BC here, the Chilcotin River, there was a massive landslide. It's blocked part of the Chilcotin River. And over this week, at some point, the water overtopped that slide and was potentially going to be coming down to our area in the Fraser. So, we're on flood watch. We're looking for debris. So this is what that day looks like. That's today. We also got to think about tomorrow, and that tomorrow's tomorrow. And there's other things like climate change. This is going to impact things like atmospheric river events, sea level rise. So I'm going to share today with you a little bit about Richmond's flood protection system. It's very resilient, robust, redundant, and reliable. And this is what's going to make us a leader in flood protection. A little bit about the City of Richmond. So we're located on Canada's Pacific coast. We're in the province of BC. Richmond is unique. We are an island. We're in close proximity to Vancouver. The US border is to the south. And we've basically a bunch of smaller islands and one of our larger islands. As noted, we are mostly surrounded by water, coastal and river. We've got the Fraser River to the north and to the south, and it's flowing westward to the Strait of Georgia, which ultimately goes into the Pacific Ocean. Richmond is very flat topography. We are low-lying, and we also have a fairly high water table, and in some areas we have some soft soils. Population of Richmond, we're about 230,000 people. A little bit about the city, mostly on the eastern side, we have agricultural. Some pockets on the north and the south side, we have some large industrial centers. And more to the west, we've got mostly single-family homes, medium density townhomes. And then generally in the center, we've got a bit of a more dense core with commercial and high density housing around our rapid transit lines. So to know what's happening, I think it's always good to talk about the past. So historically, Richmond, this is before settlement, had lots of sloughs going throughout the city. And as settlers came in, one of the things that attracted them was some good fertile soil, so great for agricultural. And some of the early works were creating some drainage ditches and access roads. And quite often, again, material would be excavated out of the ditch, which would be piled up to build a road. Similarly, around the perimeter of the island, large ditches and canals were dug, and that excavated material was used to create some of the early dikes. From the past, we can also learn. In 1894, it's one of the largest floods on record for BC. This was due to an enormous snowpack coupled with an unusually warm late spring, and this sent a lot of snowmelt coming down the Fraser River. And this is one of those things that really changed the way that the region saw the Fraser River. And out of this, the cities and the province has invested more in flood protection to prevent another catastrophe like this one. Up until the early 2000s, the province of BC had the responsibility of diking. And over the years, perimeter dikes were built and raised around the city. You can kind of see that picture on the left kind of shows what that typical scenario would look like, where we've got some raised land, some riprap armoring, and that went around the entire city. Over time, there was more densification. So what was changing from agricultural properties are now into single-family homes. So we're going to see a lot more increased densification of homes, including some new road networks and a new drainage system to support that. So I'm just going to show a video here, and this will be a little bit about the city of Richmond.
Richmond is an island city situated between the Fraser River and the Strait of Georgia. We sit about 1 meter above mean sea level. Therefore, flood protection is incredibly important. To protect us, the city manages 49 kilometers of dikes and 39 drainage pump stations. The city has a lot of infrastructure that most people never see. These protect us from any combination of high tides, snow melt, excessive rainfall, and sea level rise. The city has worked hard over the past couple decades to complete a considerable amount of projects and has planned for flood protection for now and into the future. Construction projects are designed with opportunities to enhance and protect the environment. Flood protection upgrades are paid for through utility fees we collect from property owners, as well as government grants and developers. Upgrades protect Richmond and create new spaces for everyone to enjoy. As new residential and commercial development occurs, developers are required to raise their property to meet long-term flood protection objectives, environmental goals, and the city's official community plan. The City of Richmond, investing in world-class flood protection for now and the future.
All right, so what's keeping us safe here? So our infrastructure is in great condition and it's quite reliable. We have a very comprehensive asset management plan to address our aging infrastructure, and we maintain it. We got to keep it in good working condition with pre-planned replacement. So every 2 years we do an analysis to ensure that we've got the proper funding. Most of our infrastructure is relatively new. A lot of the drainage infrastructure, that's the pipe systems, were built in the 1960s and the 70s. And one of the key things about our drainage system and our flood protection system, which is really good, is that we don't have any combined sewers, which you find sometimes in some older cities. Our flood protection as a whole is able to handle a 1 in 500 year river flooding event. And for our rainfall, it's a 1 in 10 year rainfall event. This map shows our pipe network and our perimeter dike and our pump stations. And I think one of the key things about our system, it's very robust. It's got a lot of redundancy built into it. So if you look at the pipe network, all the neighborhoods are interconnected. So from one connection to the next, the neighborhoods are all connected. Our drainage pump stations, we have lots of them around the city. So we're not just relying on one pump station. We've got, again, over 30 pump stations. If one system is down, the others could handle that capacity. Planning for change. So although we have all that infrastructure, we're also planning for the effects of climate change. The City of Richmond recognizes that climate change mitigation efforts to reduce greenhouse gas emissions, there are environmental changes that are predicted to occur, even though some of these emissions can be reduced. But to ensure that we remain safe, we are continuously upgrading our flood protection measures. So climate change, some of these impacts here, a good one is a couple of years ago, in November 2021, there was an atmospheric river event. So this is, again, a large rainstorm with extreme rainfall. This can lead to flooding. And what we've also noticed here is that rainfall over the last 20 years has increased in the City of Richmond. These are a few pictures from some other areas within the province. This is Abbotsford. And they experienced a fair amount of flooding. That flooding was due to water coming down the Fraser. It ended up overtopping some of the dikes, and there were some breaches. And this is a little bit different than what we experienced in Richmond. So for us, we did have some localized flooding. Our system performed very well. And the flooding that we had was just from the internal part of the city. So there's no overtopping of the dikes. The event was a 1 in 50 year event. We received over 130 millimeters of rain in about 2.5 days. And I think, what's really great here is that our system was essentially designed for a 1 in 10 year storm, and it performed fairly well. And this was really a great test for our flood protection system. Talk a little bit about some of the hazards that we have in Richmond. One of them is freshet. This is, again, when snow accumulates in the mountains, and then in the spring it melts. And this really translates into high river flows and high water levels coming down the river. And that rate of that melt depends on snowpack and also the heat. We've got a lot of good information. So the province runs some models. They share information with us. There's some routine meetings through freshet season. So we get lots of information. So this is the great thing, is that we can be prepared. Us and the other communities in the province get the advisories. We know what's happening. We know what the trends are. Richmond is also kind of unique in that we've got coastal and river bordering our city. On the west side, there's more influence from the coastal elements, such as tide. And as we go further east, again, it's a little bit more impacted by the freshet. Same thing with, similar to other information we've received from the province is also storm surge. So there is provincial information that, again, can help us predict when we think storm surge is coming. There's also king tides. So in the wintertime, we tend to see higher tides. A little bit about the tides. I pulled this map up or graph. This is from yesterday, and it gives us a good example of what that swing from a high tide to a low tide is. So this is in Steveston. The vertical line there actually shows yesterday about 8 o'clock. And there's about 4 meters from the low tide to the high tide. Tides are very predictable. The tides are going to happen. Again, we're not going to stop this. It's going to give us a high tide and it's going to give us a low tide. And I'll talk a little bit about this a bit later on, that this low tide is really a huge benefit to us because this is something that actually, again, we know it's going to happen. The river levels are going to drop. So unlike a lot of other municipalities where you're waiting for the water to recede, we've got the power of the tides to actually draw that water down and to take it out of where there can potentially be problems. Another good thing about the tides is that, again, being predictable, we know what that time is between a high tide and a low tide. So if we ever have an issue where we need to address it, we can see, again, how big is that window between the high and the low. Sea level rise. So when we talk about sea level rise, you can really find a broad range of modeling results and analysis and predictions. We're going to base ours off what the province is giving us. So generally over to the year 2100, we're looking for about a meter of sea level rise. And then going to the year 2200, so another 100 years, about another 1 meter of sea level rise. At the same time, Richmond is also sinking. So there's a bit of subsidence, so we can combine that in there. And that kind of, again, goes into our predictions of what we might see. So how do we plan for this? And I think one of the great tools that we have is that we have a really robust planning strategy and a number of tools that support this. So at the very highest level, we have our flood protection management strategy. This was developed about 20 years ago and has had a major update in 2019 that primarily accounted for climate change and sea level rise. The flood protection strategy has a couple of main principles. One is obviously to prevent flooding, and is to minimize impacts of flood events should one occur. And to achieve these principles, the strategy outlines a few key elements. The highest priority, and it's kind of give us the biggest bang for our buck, is focusing on our perimeter diking system. It also outlines our initiatives and goals to slowly raise the entire island out of the floodplain over time. Also some drainage improvement systems and a little bit about emergency preparedness. The next level down is our dike master plans. And what we've done is broken the city up into 5 regions and each taken one master plan for that region. This has been a fairly lengthy process for us. It's taken us about 10 years to go and complete all of the dike master plans. These are guidance documents for specific areas. And I think one of the key things that we really get out of this is that it allows us to do some early planning and better understand what is unique about each of these areas. So we've kind of broken it up so that there's kind of similar topography, similar constraints. They go into the level of actually having some preliminary design with some cross sections. And this allows us to understand what we can fit in that space. Do we own the property? Maybe we need to acquire land. Takes a look at the elevations, and maybe we can then prioritize which are the low areas. Another really key thing out of this is that because we've done that preliminary design, we're able to do a very high level cost estimate from a planning purpose. So this gives us an idea of ultimately on full build out, how much money do we need to have to complete raising our dikes? Here's a couple examples of some of the cross sections that come out of a dike master plan. So we might have something simple, taking a look at the top left, the standard dike where we have, again, our standard riprap armoring, maybe a gravel pathway on top of the dike. Down below, we've got a section that maybe shows with what the road looks like. So are there 2 lanes of traffic? Are there 4 lanes? Is there a pedestrian path? Maybe there's a multi-use path. Maybe there's a bikeway. And then some of the other concepts we have is, again, maybe how do we deal with the habitat works that might be going on in the dike? So maybe can we fit in a marsh bench or something? Do we have that property? Do we have that space? Again, this is a great tool for that high-level planning. The bottom right, we've also got a concept, our super dike concept. And this is where we'll do our dike raising, but also raise the land depth behind the dike. And this is often done with larger developments. And for them, it's always a benefit too, that again, they're getting development that's above the dike. So if there's view, maybe it's residential properties that again, they can see above the dike. A little bit more about our plans and preparation. We do lots of studies. So we have an entire engineering planning group. They look at various studies. We did one on land subsidence. So again, getting an understanding of how, we know that the city is subsiding. Is it doing that uniformly across the city? Are there different pockets? What is that rate? We've also got some seismic flood hazard assessment. So this is more a probabilistic analysis. We're doing some hydrodynamic flood risk assessment. This is we're going to model some dike breach scenarios to understand the associated flood risks. And then we've also got some emergency reconstruction strategies. So to inform us how to repair and do reconstruction if there is a breach or a seismic event. So our pump stations. As noted earlier in the video, there's about more than 30 of our perimeter pump stations. Their main role is to take rainwater that's collected within the city and pump it out. And for us, that's going out generally out to the Fraser River to the north and to the south, or a little bit on the west side. Here's some recent examples of some pump stations that we built. On the bottom right, we've got our number 2 road pump station. The inset shows what the old station looked like. So built in the 1960s, very simple, has a brick concrete building housing the pump and the controls. And through our upgrades, we're able to do a much larger building. We've added a generator. We've added some artistic elements to it. So it also becomes a feature that, again, that the public can enjoy. So with most of our upgrades, we're increasing the size of resilience around the pump stations. We are doing some ground densification. Typically, it's been with stone columns. Sometimes we're using wooden or timber pilings. We're also adding backup generators. So a lot of the old stations actually didn't have a backup generator. So this gives us increased resilience in the event of a power failure. Another thing that's quite interesting about the stations that we do in Richmond, so all of the larger stations, we use the same pump. And this is a great thing for us. And, one of the interesting things that comes up sort of during our design, and we're dealing with our consultants, they'll often tell us, this is not the most efficient pump. We could get you a different pump and it would be, increase the efficiency by a few %. And we always say, actually, no, we like the pump that we have, and we like the fact that we use the same pump in all of our stations, these large stations. And if there's ever a problem, we've got spares. Our workforce knows how to repair them. We know how to pull them out. We can actually take one pump out of a station, put it into a neighboring pump station. Another improvement that we do is a bit of a raising to the future dike levels around the pump stations. The bottom right picture, or the picture on the right, shows kind of what the outfall looks like to our pump stations. The interesting thing about what we have is we use a series of flap gates, so it allows the water to go out one direction. On that bottom picture, the top 3 flap gates are where the pump is the pump outlet. So that's the water that's coming out. The bottom are just strictly gravity gates. And this is a really good feature that we have on most of our pump stations, is that if the water is higher on the inland side, higher than what's on the river side, that water will naturally flow through the flap gates. And this condition will generally happen at low tide. If we get to a high tide state, then the flap gates would be closed because the water might be higher or same level as on the inside. And this is a really great feature because it's a passive system and it's automatic. So regardless of whether or not there's a power failure or our generator works or if it runs out of gas, we've always got this feature. And earlier, again, we talked about that tide cycle. And this is a great thing because once or 2 times a day, there's going to be extended periods of time where this system will work. We will get water out of the city. So if there's an earthquake or some other large event and some things might be going out of operation, we've got this redundancy. Talk a little bit about the Horseshoe Sioux pump station. This was one of our recent upgrades. This was done in about completed in 2020. The existing station was fairly small. It was noted for an upgrade for an increased pumping capacity. And typical to our other pump stations, this was located on top of the dike on the water side. And this one, we had a unique opportunity in that we actually own a park space in this area. And we actually looked at moving that pump station further away from the river's edge and moving it inland. And this allowed a couple of things. One is that it gave us a bit more workspace, and it also is going to protect the resiliency of the station. So if there is a seismic event, again, it's not at the river's edge. It also allowed us to have a larger platform to put some things, including our backup generator in this site. So here's a few more pictures of that, a little bit through construction, kind of gives you an idea of the extent of how much excavation work is needed. And that bottom picture, again, kind of shows you again where the old station was, again, a very small station right at the river's edge. And now we've moved it to the opposite side. Now we're going to move on to our dike upgrades. So as noted earlier in our flood protection management strategy, the perimeter dike is our top priority. Generally, we're building dikes that are higher and wider. So through our flood protection management strategy, we've set our target elevations of the elevations that we want to raise the dike to. That goes back to that conversation earlier about sea level rise. So we're aiming for generally elevation 4.7 meters within the city for the next 100 years, and then taking it 1 meter further beyond that. So this slide shows some of the things that are typical on a flood, on a dike improvement project. We're going to do some armoring on the outside. We're going to add some riprap. Not all of our dikes had riprap. Some of it, the riprap may have sloughed away. So we're going to do improvements to that. There may be opportunities for some habitat enhancements also on the outside. There might be trees in the existing dike, and these are, trees are great, but they're not great in the dike. So it's an opportunity to remove those trees, take that hazard out. We definitely don't want to have a large windstorm, trees toppling over, leaving weak spots in the dike. There's often a large drainage ditch or a drainage canal behind the dike. Again, going back to the early days, again, the dikes were generally constructed by excavating a large drainage canal and taking that material to build the dikes. We're also able to add some different amenities. So we've got some walkways and multi-use pathways and bike paths that can be included. There might also be utilities within the dike. So it's very common that there may be a water main, or there might be a hydro pole line or a gas line in the dike. And so we're taking this opportunity now to remove those utilities. Here's a few pictures of some recent construction. This is on our South Dike. Kind of shows you again the typical materials that we use. We've got an earthen core. We've got riprap armor. This is our preferred dike. If you've ever watched construction, I actually like watching, looking at excavators and dump trucks. Watching dike construction is the most boring construction there is. It's a dump truck showing up, bringing material to the site, a dozer or an excavator spreading that around, packer compacting it, and then repeating this over and over for hundreds and hundreds of truckloads. And, you might be thinking, why am I telling you about boring construction? But that's the beauty of it, that is really simple. This is readily available materials. It's very easy to find this material. One of the unique things for us is that the material that's suitable for dike fill is often found in downtown Vancouver and Burnaby when they do their large tower excavations. When the parkade, the excavations for the parkade, that material meets our dike grading material characteristics. And so that's often being able to use. One of those projects, actually here on the South Dike, the contractor that won and bid the project, we got a great price because they were actually an excavation contractor and a construction contractor. While they were doing their excavation for the high rise, they had spoil material that they needed to get rid of. And that was, again, they tested it, it met the gradation requirements, and they were able to bring it to our site. And so suddenly now, again, there's some savings on their excavation project, and that they now have a place to easily dispose of the material. And then for our dike construction project, we've got a great steady supply of material. We also kind of within the city promote circular economy, and this is a great way to talk about taking material instead of disposing it, whether that go to a landfill or, unfortunately, within this area, there's a lot of offshore dumping where material is, for some excavations, put onto a barge and taken out to the Strait of Georgia and dumped. Flood protection is expensive. Dike projects typically cost us in the range of $3 to $4 million. Pump stations are now running around $10 to $15 million. Need a big bag of cash. That's what's shown here. The city has been very successful in the past for obtaining senior government grants and funding to complete our projects. And we continue to look for these opportunities. Just recently, we were awarded approximately $13 million for one of our pump station upgrades. So I mentioned earlier, the focus is shifting towards dike raising. And this is being done to stay ahead of sea level rise. Richmond City Council recently approved accelerating our time frame to do our dike improvements. So we adopted, initially we were going to do it at about a 75-year time frame, but they've actually adopted and endorsed doing it to a 50-year time frame. This is going to cost us over $1 billion. And one of the real key things that we have in the city of Richmond is we have a dedicated flood protection utility. And this is something that's maybe very subtle, but it's a huge thing for us. And what this is similar to water or sewer, where you get your utility bill and you generally pay for the services. We've now created a flood protection utility that fully funds our flood protection, operating, and capital. What this means is that when the utility bill is paid by the residents, that goes into our dedicated funding and is only used for flood protection. This, unlike other things where you don't want it to compete. So it's a political, we're obviously in a political system. Priorities might change. So maybe it's affordable housing, or maybe it's policing. The nice thing, again, all the money that's collected for flood protection is clearly dedicated for flood protection. Our goal is to reach a $30 million target in annual revenue over the next little while. And again, this is that planning. So we understand, because we've done the dike master plans, what is that total cost? And now we're able to project out how much money do we need? and how to phase that over a number of years and how do we get to those targets. So this is, again, one of the key things that Richmond has done. We understand how much it's going to cost, and we have a strategy that's endorsed by our council and supported by our council of how to get to that plan. Talk a little bit about some nature-based solutions. So almost every diking project that we've done to date, there is some impact to the environment. And, you know, maybe it's we're taking trees out. Maybe, again, we're needing some permits from the province or Department of Fisheries and Oceans. But there's also lots of opportunities to do interesting and unique things. And so, kind of mentioned earlier, there's some chance for maybe some marsh benches and maybe some native grasses and some native trees to be put in places that work and are compatible with the dike system so that they're not going to be a risk. So again, not having trees directly in the dike core, but maybe setting them off to the backside. Another interesting thing that we're working on is a habitat bank. And this strategy is that there are always going to be a number of projects where the habitat that you might need to compensate for, you can't deal with on the site. So you might need to go to another site. Some of our projects have an excess amount of habitat, and we might be able to build some marsh benches, and others might, again, we might be deficient. And so having this bank would allow us to essentially, when we have excess habitat, be able to bank that, and then for the next project or future projects, can draw out of that bank when they can't manage that fully within the site. It also allows us to, again, maybe do larger projects in different areas throughout the city, again, that are maybe more suitable for the habitat banking. So maybe in the area where the project is, again, we don't want to do a marsh bench, but maybe there's another area where that's better suited. So again, a great opportunity to take this and manage it within the entire program. We've also got some interesting partnerships. Ducks Unlimited, we work with them, again, at no cost to the city. They had a really interesting sediment enhancement project where they were going to take dredged material, put it onto the West Dike, build some berms with the thought of rejuvenating the sturgeon banks. And this is an area where, again, over time, they've seen that the banks are slowly eroding. And so this is, again, a pilot. We're working with them to kind of monitor and see how this goes. And again, relatively simple. It takes dredged material through a pipe. The Fraser River is often dredged. So again, these are ideas that are very compatible and quite cost effective. So again, really looking forward to this project and to see how it pans out. Resources. So part of being ready. Again, the nice thing about our dike system, it's generally a very simple, robust system. We're dealing with earth core, so some gravels and some riprap armor. Again, trying to minimize hard concrete flood walls or sheet pile walls, things that, again, if we ever needed to repair, are very difficult. The city has lots of equipment. We have machinery. And again, the nice thing about our flood protection system is that, you know, we're using standard machinery, backhoes, excavators, dump trucks, bobcats with a sandbag attachment. Again, these are ways that we can protect the city. In the short term, we may also have, again, the need for some smaller sandbags. We've got some larger sandbags. We've also got good lengths of water-filled dams, aqua dams and tiger dams that can be deployed as needed if there's some localized flooding. The bottom left shows one of our satellite works yards where we have our material storage and material handling. You know, in the scale there, you can kind of see a few small excavators. We've got a gigantic pile of crushed gravel. We've also got a stockpile of riprap and large rock. And this is a really important thing. Again, going back to the fact that we're an island, if there's a seismic event, what if the bridges and the tunnels that connect to us to where we normally get our materials, what if that goes down? So again, we're fairly sufficient in, again, having that stockpile at the ready. A great way to stay dry is to be above the water. So we've got a bylaw, a flood construction bylaw. The Throughout the city, there's some different elevations where, again, looking at where you are, whether you're further to the east and more impacted by freshet, elevations that the habitable level of the house needs to be built. And you can kind of see the implementation of this through the two pictures. So the top picture shows the house likely built in the 1960s or 70s. The sidewalk and roadway, you can kind of see the elevation. There's that fence in between that and the newer house. That house is about a meter below the roadway. That's the way the houses were built in that era. Right next to it is a more modern home, and it is built above the elevation of the road. Our flood construction level bylaw dictates that all new housing, the floor slab elevation needs to be 300 millimeters above the highest crown of road. So this means that house will be up higher. If there's a low road and a high road, again, we build it again based on the higher of the two roads. The bylaw also indicates again that there should be no mechanical elements such as, you know, a heater or a furnace or a water tank that are at the elevations that are again susceptible to flood damage. The bottom picture kind of shows a more extreme area. This is in the southern area where the elevation is actually quite a bit higher. It's actually has to build up about a meter higher than the existing roadway, and again that's getting some added resilience for that home. So if you have all this great infrastructure, you got to know what state it's in. We do regular inspections by foot, sometimes by boat, and we've also been using drone technology going forward to help us. The nice thing about a drone is that we can fly the exact same path. So we can take a photo and video, have that drone fly the exact same path again. We've also got some rain gauges in the city for some monitoring. We've got various drainage level sensors in our culverts, in our ditches, at our pump stations, and also along the river so that we know what elevations and what water levels we're seeing. Another really important part is share this with the public. Certainly as the public sees things like, again, the Chilcotin landslide and worried debris coming down the Fraser or the atmospheric river event where there's widespread flooding in the province, people want to know what's happening. We've got multiple engagement events going to run through our planning department, talking about some of the initiatives as we bring our dike master plans forward. We meet with large groups. Sometimes it's with the public. Sometimes we're doing education sessions with the local schools or different community events. We love to celebrate and share all the exciting things that we're doing. We've also got a great website where we have a lot of information so that the public can find. And that pretty much brings it to the end here. This is a bit of a plug for our website. We've got a QR code there that you can scan. It kind of shows things like the video that we had seen earlier, talks a little about things that we're planning for change, some of the risks. So hopefully, again, you've got a good insight to what the City of Richmond is doing and what we're going to be continuing to do that makes us a leader in flood protection for now and the future. But thank you.
Thanks, Eric. That was great. Thomas, do you have anything you want to add?
I think there's a question from one of the audience. Louis,
Let me moderate.
Yeah, I'll let you do that.
Okay. So nothing to add to Eric's talk. So we have three questions, but feel free to add more to the Q&A box. First, Don Keefe asks, what's going on with the dikes at the east end of the island at the border with New Westminster? Is it continuous? And Don wants us to know he's with Munich Re.
Yeah, so we do talk to New West. We do talk to our neighboring municipalities. Obviously, again, a dike system should be continuous. New West also does have some strategies. At this point, again, we're going to build up to our boundary. New West, again, we know that they're also doing some work themselves and into raising their dikes ultimately as well. But yeah, lots of communication. We regularly chat with Delta, so our neighbors across to the south, they have a very similar topology to us. Quite often we bring their groups over to do some tours of our infrastructure, and they've invited us, very reciprocal. And so a couple of times a year we meet and actually share ideas of what we're doing.
Cool. Louis-Philippe Caron asks about dike upgrades. He says, great presentation. I've lived in Vancouver in the 90s. Insurance deductibles on earthquake and flood were quite high based on the perceived risks at the moment. With all the work done by the city to improve adaptation, have you seen some significant changes on that front?
I can't speak to what insurance companies are doing in terms of that. Maybe Thomas.
Yeah, I was gonna take that on. Thank you, Eric. So unfortunately, that perception is still actually kind of happening right now, right? So that's why we want to actually take every opportunity like this to kind of talk to everybody about kind of all the efforts that we put in, all the infrastructure upgrades, investment that we actually put into the industry. So we hope to actually kind of make some more significant changes in that front. So Philippe and everybody else, Louis Philippe and everybody else, if you guys want to actually kind of share the message, if you have any other opportunity you want us to actually kind of like talk to your audience about, we'll be glad to actually kind of do that. So
awesome. An anonymous attendee asks, do you have basement flooding issues in the city?
Generally, no, because there are no basements. Well, I shouldn't say no, there's very limited basements. So I think that's one of the interesting things is that when a lot of that house construction was happening in Richmond, in the 60s and 70s, we saw a number of homes with crawl spaces, but generally people did not dig and do a full story basement. And that's most likely it's cost related. If you start digging a hole, you're going to run into water. That's more costly, more problematic. So again, the high water table, again, in this case, may have been a bit of a benefit that we don't actually have a lot of basements. There are a number of properties. Obviously, there's some parkades and other structures that do go down to deeper levels. But again, they're designed to accommodate that. We've got some strategies, again, within our bylaws and policies that if you do build an underground parkade, we don't allow you to have foundation drains, because then essentially we would be taking groundwater and putting that continuously into our drainage system. So no to that. So what we see with the large parkades is that they're fully tanked. So they're waterproofed, but for that you need a fairly hefty building. So you're only going to see that maybe on, a 10-story concrete type structure. You're not going to see it on a small, 2-story, 3-story wood frame multifamily.
Otherwise, it would float out.
Likely pop up at some point.
Yeah. So, I mean, this sort of there may not be basements, but you did show us a photo of an older home with a reverse slope driveway. So presumably, you do see pluvial flooding of ground stories, right? I mean, especially with the 1 in 10 year performance objective for stormwater, right?
Yeah, we don't see a lot of that surface flooding, and our system is pretty robust again because of how it's interconnected. Again, we've got these large systems of drainage that convey the water. One of the other things I didn't mention too is that again, we generally know when some larger events are coming. Our drainage system, because we're fairly flat, there's a lot of storage capacity in there, and we actually ahead of time we pre-pump. So we draw the water level down. So if we know a big event is coming, through our operations group, they'll actually pre-pump down all the ditches and the canals and the box culverts, take that down to a really low level. And that gives us a huge amount of storage capacity. And so again, now we can do that. And then again, with the upgrades to our pump station, then we're able to convey that water faster and better out of these neighborhoods. So no, we don't generally see very often, again, surface flooding. Often it's no more to a blockage or something in that sense.
Would you know? I mean, somebody gets a little bit of water in their house, an inch or two, and it can cause, tens of thousands of dollars of damage. But would they tell you?
We do definitely log, like when we have rainfall events, we do one of the studies is to, again, see again where we get the calls, and we put them in a map. So we know again if there's again maybe a problematic area. Generally, we're pretty good. I mean, most of those issues are often on the on-site system. You know, the homeowner hasn't maintained their drainage system or their perimeter drains. Maybe again there's a blockage. You know, generally that's what we're finding.
Derek Normanton sort of asked a related question. He says that you say your stormwater system is designed to cope with a 1 in 10 year precipitation event. Why 1 in 10? And I want to preface this by saying that's not, you know, we heard last month that Copenhagen does the same thing. They shoot for 1 in 10 year flood protection. But why 1 in 10?
I don't have the true background of what I've always were designed to a 1 in 10. It's been something that the city has used for a number of years. It generally works. I think there's a balance. I mean, if you want to design something to a 1 in 50 or a 1 in 100, you'd have some pretty big infrastructure that you really wouldn't get a lot of use of. Again, I think we had a good test in the atmospheric river event in November 2021. We had a 1 in 50 event and the system performed well. So, you know, our system, again, we say it's designed to that, but I think, again, a lot of those other redundancies that we have, you know, the interconnection of the pipes, again, some of the pipes are actually oversized. Again, we have a minimum pipe size on a new development. It's a 600 millimeter pipe. Well, it probably only needs a 300, but again, we're going to build some of that storage capacity. The other thing is, you know, we're a large city that when there's a storm, it is not going to be uniform across the city. We've got kilometers. And so, you know, one of the things that we get is I'm on a system that notifies us the rain gauges. So when we hit a 2-year event, myself and a number of the other managers and flood protection staff, we get a text message that says 1 in 2 year event happening at one of our stations. Generally, it starts off in the east. From that, we actually know that it's not all across the city. So it's kind of in pockets and storm cells. So again, there's that other redundancy that the system, again, might have been designed to that, but are you actually going to see an entire 10-year storm system in the entire city? And that's not likely.
Right.
Eric, sorry, Keith, Eric, can you actually talk a little bit about this? Because I think based on our previous conversation, you mentioned there was like a comparison between Abbotsford and Richmond dealing with the November 2021 event. Like they have a very massive flood situation, but we don't. Do you mind to kind of talk about that a little bit?
Yeah, I'm gonna touch base on it a little bit earlier, but you know, for us, I guess the difference between us and Abbotsford and that large flood, what we saw in the atmospheric river event was we had rainwater in the city. That was what was causing some of the pockets of flooding. At no point did the river overtop our dikes. So our system, our pump stations, our drainage pipe network was able to, again, mostly handle all of that. Abbotsford, what happened there was that, you know, amongst all the rain that was falling in the city, they were also getting dike overtopping. And again, they've got a little bit different system with their pumps. Again, they've got one massive pump station in one of the areas. And again, it's suddenly overcapacitated. They also got flooding again from the U.S. border side. So again, a little bit different topology. And Richmond, we're kind of, you know, our own little bubble. Again, with other than the little bit of where we touch base with New West.
Awesome. Let's see. Shu Yi asks, how does land use planning and zoning come into play? I think you showed a little bit about this. Are there high risk areas where buildings should not be allowed at all? I mean, you talked about the higher risk side of town where you have a higher standard for elevation, but do you have any places where you're not allowing any development?
Well, we do have a official community plan, and this is sort of a guidance document. It's obviously adopted by council, and it talks, you know, looks into long range, again, what areas we want to have for residential. And so that kind of really outlines the overall strategy for the city. And with that, all of our drainage and as well as our water and sewer, we have plans, or it's our official community plan modeling that matches that ultimate build out. So let's say in the city center, we might have areas that are maybe now older, you know, 1-story commercial, and they're maybe going to, you know, 10, 12-story towers. You know, from a drainage point, you know, having one parking lot versus a high rise doesn't really make a difference. But on, say, on the water and the sewer side, it does. So, you know, we do have that modeling so that we know where to do the upgrades for the various utilities. Generally, I guess the other part too, and I know I showed one of the air photos, predominantly the entire east side in the center, there's something called the agricultural land reserve, and it locks farmland as farmland. You can't build a house, you know, or a high rise in this area, and so that's sort of a protected farmland area. So you know, in that area, it's mostly large drainage ditches, but we're not going to see development. We're not going to see that changing from farm to paved parking lots.
Is that because of flood risk, or is that an artifact of some other consideration?
I think it's more historic. There's also that's where the better soils are and the softer soils. So it really lends itself to the agricultural industry, and not as good for putting, you know, a high rise or a tower on there. So again, a little bit more historic.
Right. Shiva Norman Suri asks about maintenance for the dikes.
Yeah, we regularly patrol them. Kind of showed a slide of pictures of a few of our crews. We're trying to digitize that. We've got our GIS systems. We cataloged we've broken the areas up into 51 areas around the city where we collect data. We regularly monitor that. We also need to report that out to the province again on the state of our dikes. So that is something that we continuously do. When we find, you know, issues with maybe, again, some of the riprap is moving away or has been poked out from, you know, some debris coming down the river, we do replace that. And so, yeah, absolutely, we're doing a fair amount of maintenance. We also have and we call it kind of our storm watch. So when we have the high river level, so above a certain elevation, we go into storm watch mode, where our crews, again, will routinely, daily or multiple times a day, check out various areas of the dike just to ensure that there isn't, you know, some, you know, new debris or things coming down, or certain areas, again, that we know are more prone to stockpiled debris. So yeah, absolutely. And again, it's adjusted to the scenarios that we're, you know, dealing with on any given day.
Awesome. As an engineer, I was grateful for how you emphasized that boring is good. I like boring. Boring is predictable. Boring means there's proof behind it. Can you tell me what standard are there standards that you're drawing on? For example, for, you know, these habitat banks. That's the first I've heard of that. It's innovative. But are there, you know, are you following or creating standards that other communities can use? Like
Well, the
the habitat
province
banks,
has, yeah,
nature-based solutions, and the planning guidelines and whatnot.
yeah, more on the traditional side, again, you know, the earth and dike core, again, that we follow. The province has some great documents and guidelines of you know, how to build and construct and maintain dikes. Again, we've got our own standards, again, through our dike master plans and through our operation and maintenance manuals. Again, we know, again, generally, again, the gradation of the material. You know, it's a fairly standard dike cross section. We're trying to always kind of do this trapezoid dike.
Yeah.
It's simple, again, but, you know, I think the other part is that it needs to be adaptable. So the ultimate plan, we kind of have some nice flat slopes, like a 3-to-1 slope. Well, if you have all the land in the world and you controlled it, sure, you could do that. But the reality is you're going to run into some private property or a building or maybe a historic site or something in there, and you might need to adjust that. And, you know, maybe that 3-to-1 slope is now 2-to-1 slope, or maybe it's a little bit different. So, you know, I think we need to be adaptable. Certainly we have what we consider a good starting point, but it's got to be tailored, you know, to the existing conditions that are there. And the cost as well. Again, you know, if you go further out, maybe you need some private property, you need to acquire some land. Also, again, depending on what utilities, again, maybe there's a hydro line of poles, and, you know, if you can be, you know, a meter or two shorter, maybe you don't have to spend hundreds of thousands of dollars moving a hydro line. So, you know, I think it's always case by case specific, but certainly we've got a good starting point and we don't want to compromise that, but it's a balance.
A couple of attendees have asked about the recording and the deck. And just to reiterate, we always record and we always share the speakers' decks. You will find them on Monday or so at www.iclr.org/workshops. Let's see. An anonymous attendee asks, how connected are you with earthquake early warning systems, and how would the current 1 in 10, I guess that's the 1 in 10 stormwater, 1 in 10 year stormwater performance objective, be able to manage a resultant tsunami?
Yeah, so tsunami is not a huge risk for us here. Where we are, we're not directly on the Pacific. We've got Vancouver Island, Strait of Georgia, and the tsunami. Again, I don't have the exact details with me here, but again, from what we've seen in some of the modeling that has been presented to us, we're not at a great risk of tsunami. So maybe that's more, again, the west coast of Vancouver Island. So again, we're fairly lucky that that's, or again, if it is, it's something fairly insignificant that, again, more, storm surge or other things would be kind of a similar magnitude.
Cool. Going back to a second question by Don Keith. Remember, he was the one who asked about the dikes at the east end of the island at the border with New Westminster. And he asked, is it continuous? And he said, assuming yes, and honestly, I don't remember how much detail you got into your answer here, but can't hurt to come back at it. Assuming yes to his first question, is that adjacent municipality matching your diking upgrades and pumping upgrades and not be a vulnerable access point for flooding, for example, from lower dikes?
So yes, we actually just partnered with New West. They built the pump station and we give them some money to operate that. So again, I think, I've often, been told again, well, the rain doesn't know where the where the municipal boundary is. It's not going to say, oh, I fell on Richmond, I've got to be pumped through a Richmond pump station. So one of the boundary road, not surprisingly it's called that, is right between the boundary of New West and Richmond. Our drainage from some of our developments goes into a large drainage canal. They recently spent, millions of dollars doing one of their pump station upgrades. Again, some smart people figured out what's the ratio of drainage that comes from Richmond versus New West. We pay a proportional amount to them. I can't remember. It's a very, very small amount, but we paid for a portion of their pump station, and we pay a proportionate amount of the maintenance. So yes, we are in constant contact with them. We do have other jurisdictions against sort of other federally regulated. We've got the Port of Vancouver, so they control a large chunk of land. The Vancouver International Airport, YVR, on Sea Island, they actually again are a very large entity. They are also protecting theirs and doing similar dike raises. So yes, we're all in, again, very similar levels. This is a long-term, again, we're not all going to building our dikes in the next, 1 or 2 years. We're all kind of in that same 50-year, 75-year time frame. So yes, that is happening. Again, until that time, again, we also have these resources and understand, again, we've got, again, our aqua dams and our portable gear that if needed, again, we can again deploy it where needed.
Behind all the decision making, you're talking about a lot of money. Were those decisions made, that those financial commitments made sort of intuitively? Were there benefit cost analyses? Can you tell us a little bit about the process of communicating, say, to your city council, the degree of risk and getting them to commit to, what seems like a big effort?
Well, I mean, one of the things is, again, that information is out there. You see it in the news on a, daily, weekly basis. There are things, the public gets it. And when we, again, talk to the public, anytime we mention that we're going to be doing some flood protection projects, they're always supportive of, protecting the city. That's a huge thing. I think for, again, the council, again, we've been at it for quite some time. This is not a new thing to Richmond. We've been at it for well over 20 years. Again, we've been upgrading pump stations. We've been upgrading dikes. We've been upgrading our internal systems. Again, we've been at it for a very long time, and they've been very supportive of that. And I think a lot of times too, again, some of these projects are very visible. So if you do a dike raising project, we did one on the South Dike, you can see where the existing dike is. And then when you see what an extra, 1.5 meter raise looks like, and you're driving up, and you see how much wider the dike is, and the level of armor and the protection, and also the added amenities. Again, we've added this wider dike. There's now a multi-use pathway, and sometimes there's a bike lane. People get to see that, and they kind of get that, and then they can really see that difference. And so, and you know, council is also, again, very supportive of that, and they understand that, again, this is a long-term thing that you can't wait. You can't wait 50 years and then try to build it all at once. You need to have a plan and to start doing that now. And the other part is it's adaptable, right? So, you know, maybe the predictions on sea level, that might change over time. Well, we've got a great start. Maybe we need to go faster, maybe we need to go slower, but that's also built in, is that, you know, over time we can evaluate where are we at. You know, we're going to get information from the province, we're going to see things ourselves. And so, again, council is very supportive of that in terms of the flood protection. I mean, we want to protect the city. That's a, you know, that's a key thing that's been very consistent.
And I want to also add one more thing as well. You know, kind of back to the question about our neighboring municipality as well. In BC here in Lower Mainland especially, we actually have a number of basically partnership. So like the Metro Van, also the Union of British Columbia Municipality, like UBCM, they have a budget, they have a grant application. So we can actually apply to those to get some of those fundings, right? So those are actually kind of like a partnership with other municipalities. It's not just like Richmond doing all these things alone. We try to kind of like apply to those program, try to kind of like bring those initiative in to our city, get fundings for those, right? So I think there are also a lot of visibility, you know, kind of share with other municipality around us as well. So
you have to, in the United States, you have to, you want a big grant, you often have to provide a benefit cost analysis. Did you have to do that?
Yeah, grants are getting more and more complicated. So it takes a lot of resources. You know, unfortunately, one of the again, for us, what it is, it's a competitive based system. So, you know, there's let's say there's a set pot of money, maybe coming from the province or the federal government. Whoever can write the best proposal and, you know, justify what they're doing. Often these programs are oversubscribed as well. So, you know, we put a lot of effort. You know, we're quite lucky in that we have the resources and we have the budgets, and we plan for that so that we know that we can, again, put the proposals in. We don't get all of them, but certainly, again, we've had a good success rate. That is, you know, that's actually a challenge, you know, generally in the region, that the municipalities that are better set up to apply for this competitive funding likely have a better chance. There's many other smaller municipalities, you know, maybe their engineering department is a staff of, you know, 1 or 2. You know, how would they have to do that? Or again, maybe looking at their utility base and their funding. So again, it's quite interesting. We'd actually prefer that if there was more dedicated funding. Why not? You know, wouldn't it be great if, again, we know how we want to spend the money. Why don't, you know, provincial government, why don't you give us the money? Federal government, why don't you give us the money instead of always the competitive stream?
Right. So what sort of benefit cost ratios are you seeing for your projects?
I don't have the numbers in here, but again, usually through the grant applications, again, we do take a look at sort of the, you know, the loss of property. Again, we kind of look at how much value is there, what does that project cost? Certainly for us, the biggest bang right now, again, is the diking. Again, we're able to get, again, long stretches and, you know, help protect large areas versus a pump station, which again might be, again, more defined, but also, again, can protect a bit of a larger area.
Awesome. Well, that's all the questions from our attendees, and it's all the questions that I'd written down. We don't need to go the full 90 minutes. So I think at this point, I'm going to offer you an opportunity to have, you know, last thing you'd like to leave us with, and then I'll close it.
Yeah, I just wanted to thank you for the opportunity to, you know, for us to share some of our successes and highlights. And again, for us, flood protection is a major part of our city. You know, it's something we love to talk about. We love to share, you know, regardless of what industry you're in, whether that's engineering or insurance or research. Again, we're really excited about flood protection. And again, just want to thank you very much for the opportunity to present today.
Well, and thank you both for presenting. We're very grateful.
And I
Uh,
want to make one more thing, to everybody here as well. I know that the RIMS conference is actually coming to Vancouver in October. So if anybody here in the attendee, maybe attending that conference, if you guys are interested, come and actually look at the dike, just contact me. I can actually try to kind of arrange some tour, kind of take people around and show you guys as well with the engineering team, there as
Absolutely.
well.
Wonderful. Eric, would you make sure that Thomas's contact information is in your PDF so that people can, if they're coming to RIMS, they can find his contacts right there?
Absolutely.
Awesome. Thank you so much. And thanks to our attendees for coming to hear today's Friday Forum. Again, join me next week. I'm going to talk about the Jasper wildfire, and then I'm going to be on again next month on September 13th. If you're interested in reducing total cost of ownership of new buildings subject to strong wind. And with that, I will say thanks again, and hope everybody has a great weekend. Bye, guys.
Thanks.